let's remember what this actually means. If sine theta equals 2 over 3, what is the angle theta? Well, the angle theta is sine inverse 2 over 3. So what you need to do in your calculator is put in sine inverse 2 over 3. And when you get sine inverse 2 over 3, what you get there is you're going to get 41 degrees, 41.8, which rounded off to the nearest one is going to be 42 degrees. Please let me, I just want to quickly remind you what that means. If I was to draw a right angled triangle, okay, what this means is for every 2 centimeters the opposite has, it means the hypotenuse will have 3 centimeters. It doesn't mean that the triangle is guaranteed to be 3 long and 2 up. It just means that's the ratio. For every 2 centimeters it goes up, it goes 3 centimeters on the diagonal. Is that alright? Alright guys, do one more. I'll do number 9 part A. Okay? 9 part A. Once again, 9 part A is tan theta equals 1 3/5. Now, theta therefore equals tan inverse 1 3/5.
What's the theta?
Theta is the angle. It's to measure the angle. Okay? Now guys, what I'd like to say here is you can do it this way. Shift tan inverse. See this button here? Shift fraction button. 1 3/5. Okay? And then what you get here, the angle is 58 degrees. Now guys, quick note about 1 3/5. 1 3/5 is the same thing as 8 over 5, which is the same thing as opposite over adjacent. How did I know that? It is tan. That's how I know. It's tan. So this means for every 8 centimeters the opposite has, the adjacent will have 5. It could be any number. It could be 16 and 10, 24 and 15, 80 and 50. It's the same ratio. The lengths are in the same ratio. I'm just explaining what it means again. Okay? This is your answer. 58 degrees. Alright guys. That's not it. Now guys, number 15. By using the appropriate ratio, work out the measure of each of the angles marked in the degrees, correct to 1 decimal place. This angle here guys, what's this one called? Opposite, adjacent or hypotenuse? In comparison to angle A, is it the opposite, adjacent or hypotenuse?
Opposite.
Opposite, because the angle is facing it. The longest side is the hypotenuse. We have O and H. What does that mean? It means sin or sine. Sine A is 4.2 divided by 6.3. It's the opposite divided by the hypotenuse. Sine inverse that, and what do we get? Anybody? Sine inverse 4.2 divided by 6.3?
41.8.
41.8. Anybody need to see any more of them? You alright? Okay. Number 18. During a trigonometry lesson, a group of students wrote down some statements about what they expected to happen when they looked at the values of the trigonometric functions of some angles. Then they found sine, cos and tan of some of the angles. Correct the 3 decimal places to test their ideas. Here are some of the things they always wrote down. The value of any of these trigonometric functions will always be less than 1. True or false? Okay, you don't know what that means, okay? Alright guys. An example would be, here's a right angle triangle. You happy with that? Yeah? A standard right angle triangle. Okay? This here is length 5. What can you guarantee about the hypotenuse, guys? The hypotenuse is what?
The longest side.
The longest side, isn't it?
Yeah.
The adjacent and the opposite can change around. Okay? They can be either bigger or smaller than each other. Now, when you write down the functions, okay? Sine theta, cos theta and tan theta, what you know is that sine theta is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Now guys, Which number is always bigger, O or H? Which one's always bigger? H. So this means that it's always a fraction less than 1. Sine is always less than 1. What about cos? Is the adjacent always smaller than the hypotenuse? If it's a triangle. So this means that this one here is also always smaller than 1. What about tan theta? In this one it's 4 over 3, which is bigger than 1. So what it basically is trying to say is that cos theta and sine theta are always guaranteed to be less than 1, but tan theta isn't. Do you understand? Tan can be any value. Okay? So that's false. Now guys, what about the next one? If the size of the angle is doubled, then the value of the trigonometric function will not double. Is that true or false? Do you remember I did it yesterday? What's sine 30 in the calculator? Sorry? Alright. What's sine 60?
Root 3 over 2.
Which is the same thing as 0.866, yeah? Guys, when the angle doubled, did the value of sine double? No. So if the size of the angle doubled, then the value of the trigonometric function will not double. This is true. It doesn't double. It'd be the number 1 otherwise, wouldn't it? Okay, the value of all the trigonometric functions will increase if the size of the angle increases. Do you think this is correct? Value. Okay. Once again, guys. Okay. Let's look at an example here. Okay. We have sine theta, cos theta, and tan theta. Now look at this. Okay. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Now look at this, guys. Okay. What type of angle am I starting off with here? Can anyone tell me? What do you think of this angle here? Very small, isn't it? Now, when it's very small, which side is very large in comparison to the other one? Hypotenuse is always the largest. That is unarguable. Which one's much longer, the opposite or the adjacent? Adjacent, isn't it? Yeah? So, at small angles, cos is going to be bigger or smaller? The length of the adjacent is going to be bigger or smaller relative to the other sides? Look at it. Is the adjacent big at the moment? It's nearly as big as the hypotenuse. Okay, now look at this. What happens when I increase the angle up? What happens then? The hypotenuse becomes much bigger than the adjacent. Now what happens when I go all the way up here? What now? What do you think now? The opposite is much larger than the adjacent. So guys, as the angle gets bigger, what happens? What happens to sine? Does the opposite get bigger or smaller relative to the hypotenuse? Sorry? It gets bigger. So this means that it's going to be getting bigger. As the angle gets bigger, does the adjacent become bigger or smaller relative to the hypotenuse? Look again. Bring it all the way back down. Is there much of a difference between the adjacent and the hypotenuse at the moment? Now look what happens when the angle gets bigger. What happens now? The hypotenuse is much bigger than the adjacent. So this means that the adjacent gets smaller compared to the hypotenuse, which makes the value go down. Okay? And what about this value here? Opposite over adjacent. Okay, once again, for a small angle, which one's bigger?
Adjacent.
Which means that it's going to be a big fraction. It's going to be a fraction, isn't it? It's going to be something like a third. But when the opposite gets bigger, what happens? the value goes up. Okay. How would you prove that to yourself? Which has the bigger value, sine 30 or sine 60? Which one's bigger? Sine 60. Cos 45 or cos 60? Which one's bigger? Which one is the bigger value? Cos 45 is bigger. Okay, and finally tan theta. Tan gets bigger as the angle gets bigger. So tan 80 is bigger than tan 60. Is that right? Alright guys. Alright, and the best way of looking at it would be like something like this, okay? And I will leave it there, to be honest.